You're all good.
Okay, thank you. So, how I already introduced, the tech talk is about my startup Voptop. That is a shortcut for voice over peer-to-peer. And let me give me at first you a short overview over the presentation. At first, I will tell you what Voptop is, and then I will tell you how it works. While I'm telling you how it works, I try to explain you a little bit about peer-to-peer networks, how peer-to-peer networks work, a little bit about the fundamentals, and how peer-to-peer networks are used in Voptop. And then I will give you a short introduction into encryption. What are the basic goals of encryption, what kind of encryption exists, and how is encryption used in Voptop. Voptop is a network application based on peer-to-peer networks, so there's a protocol. Then I will try to explain you about the Voptop protocol, then a little bit about audio and video encoding in Voptop. So that's it basically. If you have questions, ask. In best case, after the presentation, and if you have problems in understanding or whatever, just ask while the presentation. I try to answer them. So, what is Voptop? Voptop is an application for voice over IP, video chat, instant messaging, and screen sharing, and provides end-to-end encryption and anonymous connections. That means it does not just encrypt the data which are transferred, it tries to make the connection anonymous, and in this way it protects the metadata as well. So if person A is communicating with person B, it should not be visible from outside that this specific persons are communicating, because this information can be important as well. For example, if you are a whistleblower, it's important that your company or whatever you are working for, which are your whistleblowing your informations, can see that you are, for example, in contact with a journalist. Then the information that you are in contact with a journalist, for example, is important as well, like the data which are transferred itself. So how does Voptop achieve these goals? That's explained now. Voptop tries to avoid direct connections. A direct connection can be observed. So if someone has a possibility to observe the network you are using, he can see to which specific endpoint you are connected. So if you have a simple socket connection from computer A to computer B, someone who is able to observe the whole network can easily see to which endpoint you are connected. So Voptop tries to build indirect connections and tries to route the connection through other peers and anonymize the connection on this way. To hide the connection, it's necessary that it's not just a few peers in the network. The network needs as big as possible. Now that's not obviously seeable which communication participant is communicating to another. To archive this, Voptop builds a peer-to-peer network. I try to explain you the fundamentals about peer-to-peer networks. A peer-to-peer network is nothing else than a distributed application architecture. It tries to partition tasks and workloads between peers. In the case of Voptop, it uses the peers to tunnel, build a connection through other peers to the endpoint and to anonymize it on this way. So it's basically using the peers to route the payload, the data, from the sender to the recipient. And basically the peers should be equal privileged. That means in a peer-to-peer network, a peer is providing a service and consuming services. regular client-server architecture. There's a server providing some kind of service, and the client is consuming this service. For example, a web server providing websites, and the client with their browser connecting to it and consuming this. On a peer-to-peer network, this should be equally privileged. That means you're providing a service and you're consuming a service, in best case. For example, if you use the peer-to-peer network for file sharing, that means you share a file by consuming that files. There are typically two basic kinds of peer-to-peer networks. The first is unstructured. Unstructured is the first generation peer-to-peer network. That were the first peer-to-peer networks which were implemented, founded, however. And they are divided in 3 subclasses. The first one are the centralized P2P systems. That means they have the P2P network centralized around mostly a server. The server is managing the peer-to-peer network. So, for example, if it's used for file sharing, the server would have a kind of list of files which are shared and who is sharing them. If you are searching for a file, the central instance, the server would be asked, and the server tells you which client has the file, and you can connect to. Then there are the peer-to-peer networks. This means there's no central instance. They are self-organized. They are pretty simple to implement on local area networks, where you have the possibility to send broadcast or multicast signals. That means you send just the signal on the network, and everyone on the network is connected can read the transmitted data. That's obviously not an option for the internet, because if every connected peer could send a message which is received by every connected other, that would end in chaos. So that's just not possible. But you can implement a peer-to-peer network on the internet as well. What you need then would be first entry point. So every client which connects to the peer-to-peer network would at first have a list stored itself to know that their other peers can ask them for the rest of the peers. So you need just a first list of peers if you're entering a peer-to-peer network, which is a peer-to-peer network. Then there are hybrid models. That's basically a mix of centralized and pure peer-to-peer networks. So usually they have a centralized instance, which is a pure peer-to-peer network, and that builds a central for the centralized peer-to-peer network, even though it's a hybrid peer-to-peer network. Then there are the so-called second-gen peer-to-peer networks. That is the so-called structured peer-to-peer networks. They are based on distributed hash tables and are mostly pure peer-to-peer networks. The key of these structured peer-to-peer networks is that they hold a search index which is distributed over all peers in the peer-to-peer network. So if you want to search for anything in the peer-to-peer network, then it's, for example, for file sharing, you ask one specific peer, and it directs you to the next peer until to the position where the information are stored. So it's a very efficient self-organizing peer-to-peer structure, and highly efficient in searching. That's, for example, BitTorrent is based on a structured peer-to-peer network, which is using a distributed hash table. So, what kind of peer-to-peer networks are used in Voptop? Voptop takes advantage of both unstructured and structured peer-to-peer networks. Voptop has a central instance. That's a pure peer-to-peer network. It's created by the Voptop servers and is based on a distributed hash table for searching. This pure peer-to-peer network builds the central instance of it and organizes all the rest of the peers. The centralized peer-to-peer network around this peer-to-peer network, that's again an unstructured peer-to-peer network, and that's formed by the usual client. So if you use the Voptop messenger, this is one of the centralized peers, which are forming the unstructured peer-to-peer network, which is again a centralized peer-to-peer network around the peer-to-peer network. So if a client wants to connect to another client, it asks the peer-to-peer network for the specific information to search the client, find a connection for him, and the peer-to-peer network, which builds the central instance, returns the information, and the client can then build it. Later we will see a little bit about the protocol. I will show the protocol how it works. But that's at first the basic about the network behind Voptop. Now let us get us a little bit into encryption. Now, at first, the fundamentals. Encryption wants to protect. It wants to protect the information. So encryption has protection goals. The first protection goal is the message should be understood only by those authorized. That means if person A sends a message to person B, just person B should be able to read the message. The second is the message should not be manipulated. That means if person A sends a message to person B, someone between is not be able to manipulate, or if he manipulates, the message gets more or less destroyed, not readable, so it can't just easily be replaced by another message. And third, the vendor should be authenticated. So the recipient of the message should be sure about the sender. So that are the three main protection goals of encryption. And there are different kinds of encryptions you can use to achieve this goal. They are basically divided again in two upper classes that are symmetrical encryption and asymmetrical encryption. The symmetrical encryption means you have one key for encrypt and one key for decrypt, and that's exactly the same key. So it's basically like your door lock. You have the same key to open and to close it. And then there's the asymmetrical encryption. That's basically two keys. You have one key to encrypt data and one key to decrypt data. Mostly the key to encrypt is a private key and the key to encrypt is a public key. So you can just give your key away and everyone can encrypt with your public key your information, and you are able to encrypt the data with your private key. And as long as your private key is secret, no one then yourself can encrypt the data. So why they are both technologies? When asymmetrical encryption gives us a possibility to give other people the possibility to encrypt a message without having a common secret with me, why we should still use symmetrical encryption. Symmetrical encryption has the advantage of performance. Asymmetrical encryption is very CPU intensive, so it needs a lot of calculation power, and you need long keys. For symmetrical encryption, the most common algorithm is, for example, the AES algorithm. It's already secure on 128 bits. If you are a little bit paranoid, maybe 256 bits, but with this key length, it's pretty secure if you have a random key, which is not easy to guess. On asymmetrical encryption, you need a much longer key length. Usually, we use a key length of 2048 bit, and it's much more CPU intensive if you encrypt something with it. So both encryption types are useful. It's not that you can just easily say, okay, I use asymmetrical encryption for just everything, because it's easy. We don't need to find a common secret for symmetrical encryption, which would be the key for encryption. We need both, especially if we have live data like video streaming, which should be encrypted. To do this with an asymmetrical encryption would be a bad idea because of the CPU use. So what kind of encryption is used in Voptop. Voptop takes again advantage of both. Obviously, we are streaming video, for example, for video chat or for screen sharing. So trying to encrypt all the data with an asymmetrical shifter would be a bad idea, just too slow. So we use both. Asymmetrical encryption is used as in the first line for communication with the server peer-to-peer network. So we don't need any kind of common secret. So we don't need a key definition. We just encrypt all communication with the peer-to-peer network with RSA. So that is one of the algorithms which are asymmetrically, and it's used for building a connection between the clients. Later I will say a little bit more to the protocol, then it will be more clear why we are using asymmetrical encryption for building the connection to other communication participants. And then is the symmetric encryption used in Voptop. That's used for encryption of the payload. So the video streaming, instant messaging, whatever is sent over the Voptop network is encrypted symmetrically, and it uses the XTEA algorithm. That's the extended tiny encryption algorithm. It uses a 128-bit key and is a so-called block cipher. So now to the protocol of Voptop. All connections are not built directly. That's what I said at first. That means that there are peers between you and the connection recipient. So, to archive it, Voptop uses a hierarchical protocol. Every hierarchy level represents a peer between the communication participants. And it covers in the last layer the content for the payload of the protocol. The payload of the protocol is, for example, the information, what kind of request is it? Is it a request for a video chat, for an instant messaging, whatever? And it covers a random number, which is generated by the communication requester. The random number is used for authentication. So if person A tries to communicate with person B, it generates a random number, encrypts it with the public key of the person he wants to communicate to. Then he gets an intermediate client that is provided from the peer-to-peer network. This client gets connection information to connect to the communication recipient. This again gets the next peer, the intermediate peer, with again the information, and that is repeated in a way always for every peer which is intermediate for the whole connection structure. The last, so peer n-n, is a peer yourself connecting to. So if person A is connecting to person B, person A connects to peer n-n, so the first peer in the row. He connects to the next peer until he's on the last peer and the final destination, the person you are trying to request. So it's very inspired by the onion routing. You maybe have heard it. That is a protocol for anonymous surfing in the internet. It carries the same idea, but just not for connecting to websites. It's for video chat and so. Yeah, that's the way the Voptop protocol works. Pretty simple. I hope so. Yeah. So last but not least, Voptop is basically a video chat and screen sharing application. So it has video and audio encoding. For audio encoding, Voptop uses Probus currently, and for video encoding, it uses H.264. That's just the codecs which are currently used. They should be replaced very soon, and replaced through VP9 and Opus. So because they are open standards, more or less open standards, they are open codecs, and that's why they should be replaced. Currently, we are using the FFmpeg library for video encoding, and the default libraries for Vorbis, which are provided from the developer itself. Yeah, that's it.
So, does anyone have any questions?
Exactly, there are questions.
Any questions about news? I don't think there's any questions. Or, well,
what does he do?
so are you one of the system architects for Vaptop, or what specifically do you do?
I'm the founder of the company and the coordinator. So a big part of the code by myself. Especially everything around the encryption is done by me.
So the encryption is done by him. He does most of the system.
Mostly.
Gotcha. And are there any resources you'd recommend students interested in encryption to study or look at if they want to learn more?
Start with mathematics. To be honest.
Start looking at what? I'm sorry.
Start with mathematics. To be honest. It's
Which
a very task. Really good literature. The first time I came across encryption was while I was studying IT science. That was how I get in contact with it. So the real good books, especially in English, I wouldn't know which to suggest. In best case, your university has maybe a lecture encryption. I think that's the best entry. Trying to get into encryption on yourself is very hard and difficult. If you want to get into encryption from the developer point of view, not from the theoretical point of view, if you don't want to do the math all yourself, if you just want to develop with encryption, it's maybe a good idea to start with the OpenSSL library. They have a lot of implementations around encryption, much more than just the algorithms. They have implementations for authentication and from operation modes. Just the encryption doesn't help you to implement secure systems, especially if they communicate over the internet. There's much more necessary. So, and this library does a lot of for you. I'm not a big fan of this library, to be honest, because of a lot of security leaks which were found in the last weeks and months in the OpenSSL. But it's a good library to start if you want to develop with encryption, if you want to develop maybe a known network application which should encrypt its data it sends and receives OpenSSL as a good entry point. It helps a lot.
Sweet. Yeah. Thank you for answering my question. We have one more.
So he protects these video chats and phone calls for encryption. Do the people behind Voptop monitor or see or know who's calling? Like, can they watch or monitor these calls even while other people can't?
Can you hear him or no? 1 second. So his question was, are you able to actually see, you know, as admins, all the information that's going to one point to the next, or is it completely private even too?
It's completely private.
So even to the admins or architects working on it is completely...
Absolutely, there's no way for them to get the information. The connection is never done to any kind of service. I told, wait a second, I go. Exactly the layers of the peer-to-peer network. I told that the peer-to-peer network is split into two parts. The peer-to-peer network, which is a centralized instance, which organizes the whole peer-to-peer network, especially the clients around. But the traffic, the communication traffic, is really never routed through this instance. So it's not even close to the admins. So no one from the admins can ever get into the data. The data is just routed to the peers, which are connected to the peer-to-peer network. So if you're logging in with your client is not just your client for chatting, for video chat, whatever. It provides even the service for all the others to route their traffic through their client to the recipient. So the traffic is never routed through the server instances, and so even the admins can never access anything. Basically, they are holding just a phone book with phone numbers.
Trying to make it easier and it didn't work. You had a question?
Yeah. How big is Voptop's current user base?
How big is Voptop's current user base?
Currently, it's a few hundred users. It's not so big. It started just last year, end of last year, middle of December.
A question I have is, what are some security flaws that you currently see with Voptop? As in things that might be exploited, or things that may not, are like gray areas currently in architecture?
The most risk for Voptop, we are using the OpenSSL, which I suggested for a good entry point for developing. We're using it in Voptop as well for the RSA algorithm. The RSA algorithm is a very complex thing. It's not easy to understand, not easy to develop it yourself. It's a good idea to use it from a library, but that's a big entry point in my point of view. So being depending on other libraries, for example, the OpenSSL is one of the biggest threats for Voptop security, in my opinion. And for sure, what's every time a threat is your own computer. Voptop can be secure if you're hosting it on an infected system. It doesn't matter how secure Voptop is anymore. But the real threat for Voptop comes from its dependencies. We are using, for example, the Qt framework for developing. And if this framework has bugs, it would infect Voptop, for sure. So the most security risk came, excluding maybe own mistakes. We all make them, our developers as well. But the biggest risk, especially because we don't have it in our own hands, comes from dependencies which are used for our application, which we don't have in our hands, like the OpenSSL or like the Qt framework, which we are using. But you can't really exclude this from your project, because if you try to exclude this from your project, that means you have to do completely everything, including UI, including low-level network programming, and yeah, basically just everything on your own, up to the XML parsers. So you have dependencies in your project, and they can become a problem if they have bugs. They are a possibility for a threat. I hope this answers your question.
Yep. Does anyone else have any questions, or? I think we're all good. Thank you again, Ryan, for speaking. And would it be possible for you to send me the slides so other students can see them as well?
Absolutely.
Sweet. Well, thank you again for presenting for us, and we greatly appreciate it.
Okay, thank you.
Thank you again.